a wonderful device, and I highly commend it to you, because the way we used to find out about an antenna, what it would do was put an SWR bridge on it. We would look at the SWR, would send a little signal from our transmitter, test it, and then see what it was doing. And if it wasn't on the right frequency, well, we had to tune our radio a little bit, try to figure out whether the antenna would be longer or shorter. Yes? This is a Comet CAA 500 Mark II. They made a Mark I for a number of years. MFJ makes about 4 different models of this, but this is the Comet. And these, I checked the price today, it's like $3.99 on HRO, and everybody, you can buy one of these. So this is really sweet, and in the old days of tuning an antenna, you would go out and flip a little wire off your dipole and hope you needed to raise the frequency and by cutting it, but if you cut too much, you were screwed, because you were going to have to try to add some more length to it, which is a lot harder to do than cutting wire off. But with this, you can go in and find out exactly what frequency the antenna is resonant on, and not only tell you SWR, but it'll actually tell you the impedance. And because sometimes you'll get an SWR meeting that sounds like it's really good SWR, but it's a bad impedance, and you don't want to leave it and transmit into that. So this does both. On this dual meter at the top, it shows SWR on one of these 2 cross needles, and on the other needle it shows impedance. And it's got a sweep function where you can tell it, well, I want to tune an antenna for the 144 megahertz 2 meter band, and tell me where this antenna's, what the chart is on where the lowest resonant frequency is. All right, this is a dual band antenna on a magnetic mount that I stick on here. I've got it connected. I'm on the 2 meter side. I'm going to tell it to sweep the center frequency of this antenna, and it's starting at about 144, and it's drawing a little graph right now on the LCD display, and it's going to show me that graph in a minute and tell me if this antenna is resonant anywhere. Right now, it doesn't look like it's doing much. So let's see what we got. Going to turn off the graph.
Need a ground plane for it?
Put it on the metal chair.
That's what I'm about to demo in a minute. This is an antenna that requires a ground, and it's telling me that the lowest SWR is 5 to 1. That's not going to work. That's a bad idea. And the reason is because this antenna requires a ground under it. So I'm going to take this antenna off, and I'm going to swap it for a model that is designed, this is a gain antenna, but this is actually manufactured to not require a ground. It's got 2 advantages to that. So now I'm going to tell it to sweep this antenna, and let's see what it does. It started at 144, and it's working its way up, and it's drawing a little graph at the bottom of the LCD display, which is, I'm sure you can't see it, but if you were holding it in your hand, you could see it. And the impedance and the SWR are being shown here. So it's drawing me an SWR chart of this antenna showing me that the SWR is 1.1 to 1 at about 145 megahertz. It plotted it on the graph on the bottom. And that's the difference between an antenna that doesn't require a ground, like this one, and one that does require a ground. Now, the little short one works pretty good on the roof of a car because it's got a ground under it. But it proves the point that this antenna is not going to work. You're not going to get anything below about 6 to 1 SWR if you don't mount it properly wherever it is you're mounting it. This one has a lot of other information. You can manually tune it and watch the needles to see where you lower it, where you find the lowest SWR while you're still hitting about 50 ohms on the impedance. One of my friends came over last, I don't know, 4 or 5 months ago. He had an intermittent problem with his mobile installation. He had a 2 meter 440 antenna on the roof of his truck. And he said, I think I'm not hearing like I should. I think there's an issue with the antenna. So we put this on, and before we even did anything, I said, I'm going to jiggle the coax while I'm watching this. And the SWR was going like this whenever I jiggled the coax. So we We got out the wire cutters and we cut the PL259 off and we put a new PL259 on, problem solved. The problem was in the connector, and we identified it right away by moving it, and then we swept it and we saw that the SWR was perfect. Nothing wrong with the antenna, nothing wrong with the feed line. There'd been some stress, I guess, on the PL259 on the end of the cable, and it identified it instantly for us without having to spend a lot of time doing it. So it's a great tool, and you can use it. This one goes from 1 megahertz up to 480 megahertz. So it covers pretty much everything we would do, and it's great for measuring a dipole. You're putting up a simple dipole in your backyard. You want to figure out how long to get it exactly right. You cut it according to a chart. You put this on it, and it'll tell you where the resonant frequency is. You know if you need to cut a little off the ends, add a little bit to it, and you can tune it for exactly where you want. So, antenna analyzer, great piece of equipment, and not everybody needs to own one. If you can borrow one, and the club now has one. So.
Does that one have a frequency counter on it?
Does it have a what?
Frequency counter.
It doesn't have a frequency counter. It has a digital display. You dial in the frequency you want, but it will not tell you, what the frequency of your radio is. Now, we've got something else here that'll do that. But this is just for that. This has, if you're interested, it has 2 antenna jacks. The one on one side goes from 1.8 to 300 megahertz. On the other side, it goes from 300 megahertz to 500 megahertz. So you have to put an antenna, depending on which band you're working with. You have to switch it to the appropriate connector. But it's pretty neat. It's got 6 AA batteries in it. It lasts me about a year on a battery charge, so it's pretty efficient. Another tool that I've had since I was 16 years old, and a lot of hands have these, and one thing is, nothing has changed about this except the price, about 50 years. This is the original Bird Model 43 watt meter. Uses the plug-in slugs for different power ranges and frequency ranges. And I got this when I was 16 years old. I think they cost, I don't know, about $100, and the slugs were about $20 at the time. I think the base meter now is like $300 and some dollars, and the slugs are around $100 to $150 if you buy them brand new. But I've bought slugs over the years at Hamfest where somebody's selling them, because unless you drop this thing and totally destroy it, the slugs last forever. And it's a great tool. It shows forward and reverse power. You put your transmitter on here, your antenna on here, you key the radio, and you can see how much power it's making in watts. And if you want to see the reflected power, you turn the little knob and reverse it the other direction, and it shows you how much reflected power. But the beauty of this is if you've got a 50-watt 2-meter radio and you want to know how much power is my radio making, this won't just show you SWR, it'll show you in watts. Your radio is putting out 50 watts, or maybe it's only putting out 5 watts, and there's an issue there. And looking at the reflected power, if you know how to do the math, you can actually compute the SWR. This doesn't compute it for you, but Bird makes a little plastic chart that you can get that allows you to look at the lines and see forward power is this, reflected power is this, and SWR is the difference between those numbers with the appropriate formula applied. So it's wonderful for testing an antenna. Every two-way radio shop in the world has at least one of these, and probably a half dozen of them. They're about as rugged a piece of equipment as I've ever seen.
What's on the side right above the plug? Other sides?
This is an extra slot for extra. You can put 2 plugs on the side, spares, plus the one that's actually active in the unit.
When,
yeah, Richard.
I don't know if you know it or not, take the plug when you're not using it and revert it and turn it halfway between the 2 sides.
In the middle.
And it puts the meter in park.
Oh, okay.
And it quits bouncing, and it no longer bounces while you're traveling and everything.
Yeah.
It shorts out.
How about
Shorts
that?
it out where the meter is not bouncing, the needle is not bouncing while you're traveling.
Look at that. It took me 50 years to learn that.
I've got one up at the house and I keep it.
Yeah.
You can download the chart for free too.
Yeah, the chart's on the internet now. But it's sometimes you just want to know SWR, but a lot of times actual power out of the radio is important to know, and this will tell you power out.
That was supposed to be like, the bird is supposed to be like one of the most accurate ones, right?
Yeah.
Because it's like, I tried to see how low my radio could go. The manual says it goes down to 2 watts. But every watt meter I would hook up to it says 3.
Well,
But I don't have a bird.
well, you need to have the slug that has the proper resolution too. If you're measuring high power, obviously you've got to have a slug that goes at least that high. But if you're measuring low power and if you're trying to measure a 10-watt radio, you don't want to put a 1,000-watt slug in here because the needle's going to barely move and you won't be able to tell what you're doing. So I have slugs that go as high as 5 watts full scale for measuring, say, an HT that puts out 5 watts. But this is a 100-watt slug for 100 to 250 megahertz. And the one on the side is a 50-watt slug for 400 to 1,000 megahertz. So this, you need to get, if you want resolution, you have to have the appropriate slug to tell. And of course, buy a separate slug for $100 a pop. So you try to find one that will cover most of your needs so that you're not buying a 5-watt, a 10-watt, a 20-watt, a 30-watt, a 50-watt, and so on. But I think I have a 1,000-watt slug for HF. But this is primarily I use these 2 slugs for the 2-meter and UHF mobile radios and the D-Star repeater. We check the power on that with this sometimes. So that's the Bird watt meter. Now at my HF station at home a few years ago, I broke down and I bought an Alpha watt meter that is not the sorry, somebody's got a radio in here. The Alpha watt meter I leave in line for my HF antenna, and it's got 2 displays. It's got an analog display that shows SWR on a needle, and it's got a digital readout for watts out, the forward power, and it's pretty sweet. This is not something you want to leave in line at your base station, your HF station, and try to look at it all the time, but they do make things that are designed to be left in line, like Alpha makes some. I'm sure MFJ makes some, but it's nice to be able to key your radio and see, oh, it's putting out 1,000 watts or it's putting out 1,500 watts. Or in the case of Mike Owens, it's putting out 5,000 watts. Mike has to buy slugs that most of us will never need. But they do. It's a great piece of equipment, and I recommend that to you. You can buy these used, you can buy them refurbished, and they're always for sale. Okay, let me show you something else that I'm sure everybody here's probably got. And I brought 1, 2, 3, 4, 5 of them because they're all different. Everybody's got a digital multimeter of some description. This is my very basic one. I bought this, I think, at Frostfest at the show place, which would have been a long time ago because Frostfest hadn't been at the show place for a long time. But this is a good little meter. It does, AC, DC voltage, ohms, has a few little current ranges for even microamps, milliamps, and then up to 10 amps if you put it in line with the load you're trying to do. And it's got a sort of readable LCD display. Let me see, I think it's got a light on it, maybe. It doesn't have a backlight on this one. You just got to be able to read it in the light that you're in. Let's see if I can do a little demonstration here. I'm going to plug this into the back of this UPS here. Yeah. I'm going to see what the...
See the smoke come out?
Yeah. And his ears. Okay. It's reading 117 volts AC coming out of the UPS here. Now, I'm going to pull power. If I do that, it's going to take a whole bunch of things. Yeah, I can't do it. It's hardwired. All right. Well, I'm not going to be able to do it without screwing things up, but I did it this morning. And if I pull the power and the UPS starts to feed it, running off the internal battery, power drops down to about 90 volts. It shows 90 volts voltage coming out. Anybody want to guess why it shows 90 volts instead of 117? Square wave, exactly. This is not an RMS voltmeter. This is a low-end $20 Chinese voltmeter that is fine for a lot of purposes, but it's not what we call a true RMS voltmeter. So when that square wave comes out of that low-end UPS, because it's not a sine wave UPS, it's a square wave UPS, simulated sine wave they call it. It can't read that accurately. But this one is also a Chinese meter that has all the same functions, and it says RMS-DMM. When I bought this at Dayton a few years ago, I told the guy running the little booth there, I said, I want your least expensive true RMS meter, so when I'm replacing the batteries in these UPSs, which seems like I do every month, I got a UPS needs a battery, I can take this and I can pull it, the battery, pull the AC off, and I can see what it's doing, and I will know that it's actually putting out. This has got a pretty decent little display with the backlight on it. It's not bad, and this was about $70 at Dayton. So it does everything. About $70, 70. Now another neat feature is it's got an optical port on the top, and if you buy their little interface, you can plug in an optical port that has a USB connector on it, and you can actually plug this into a computer and log data. And I'm going to show you in a minute how that works on another device. But if you want a better than low-end meter, get a true RMS meter like this, and it does all the normal stuff: voltage, current, continuity, and it's got a few other little features on here. I think it actually reads frequency. I see a cycle button on there too. So that's a nice upgrade. About 2 years ago, I was crawling around in the back of a car, an old car that has a battery under the rear seat in the car, and it looked like I had a dead battery. I was in the garage, and I was holding a flashlight in my mouth, and I was trying to take this meter and read the voltage, and I couldn't really read it, and I was trying to figure out, was the battery dead or not, and it was a big chore. And I said, somebody's got to make a voltmeter that has a better display that's more readable than these passive LCD displays. So I did some looking, and yeah, you can find them. Agilent makes one, and Brewer works for Agilent, by the way. What used to be Agilent, Keysight now. This is the Agilent Keysight, and this is the most readable display that I could find. This is it's a digital voltmeter. It's got a few extra functions. It'll measure frequency. It'll measure temperature. In fact, it's showing the room temperature in the top right corner right now on here. It does current. It does continuity. It's got some data storage functions where it'll store your readings in the meter. You can go back and look at them later. And it's the sweetest meter I've ever bought, and it costs as much as a really nice 2-meter radio. So you got to decide what you're going to use it for. And I was in a mode where I was very frustrated because I couldn't get one of these meters to do the job I needed. So I said, "The hell with it." I found an online place and I ordered it, and this is it. But I'm going to show you something else that doesn't do it.
A lot of the classes that I teach, people starting out, I recommend, I tell them, go down to Harbor Freight Tools. You know, a lot of times you got a free coupon, you can get, some sort of digital meter, and they got a variety of them, to at least learn what they do.
Right.
And then once you do that, you figure that out, then they have the opportunity to look at a lot of other options and spend a little bit more money on something reliable.
Right. I made it for 54 years without needing this, but I broke down and
Wouldn't it have been cheaper just to buy a new car battery?
Yeah, but I've got 7 cars, and I'm always buying batteries. So, but it would have been cheaper to buy a battery. I could have bought 5 batteries for what this big cost.
How do you get the data?
I'm going to show you how you get the data out. But let me plug this in. Actually, I can plug it into the power strip here. I'll show you one kind of neat feature here. Get it on here.
Stick it a few times.
Okay, it's reading our line voltage as 116.72 volts. You can almost read that back there because it's readable. Now I want to find out something else about the power here. I want to see what frequency Virginia Power is giving us. Well, they're giving us 59.991 cycles of AC too. So we can look at frequency and we can look at voltage simultaneously on the display. And it, like I said, it does all the other features you would expect. This one even does capacitance too, by the way. You can put it
It
down.
has a hold, a peak hold.
Yes, it has a peak hold on here where it can hold the highest readings. It'll show minimum and maximum values, whatever your highest and lowest was, and it pretty much does everything that a meter would do, plus a few other things.
How many hundreds you said?
That's one of those things you don't tell you what you pay for that.
Hey, man, like that, Tom, can't get no individual school.
Yeah, that's right. That's right. They say if you buy the right tool the first time, you'll have a value. Okay, now this is almost the same meter that I found on eBay about 6 months ago, and a guy must have had like 50 of them because he was selling them just like crazy. The only difference is this doesn't have the organic LED display that one does, so you can't really read that very well. Now, the disadvantage to the OLED display is in bright sunlight, that is not a good display. That's hard to read in bright sunlight. In ambient light or dim room, that's the best you can buy in terms of a display. But this is a normal display right here, and if you push the button on it, it lights up, and it's a pretty good readable display. You can easily read that, but I couldn't pass it up because they were going for less than half price. They were brand new in the box, never been opened, and they had the factory calibration certificates and all the accessories. I'll tell you what this one is. This was $225 on eBay, but if you bought it new, it's $500. Yes?
And you have to have it recalibrated?
No, it's still, I mean, they basically say the calibration is normally good for about 3 years on the certificate they give you, so I'm not there yet. But I'm going to show you how to calibrate your meter for less than what Agilent would charge if you want to send it back. So there's something on the back of this. I don't know if you can see this little device. It's got a green light showing on it. This is a Bluetooth module that is taking the data from the meter and sending it out over Bluetooth. So let me see if I have got things lined up here. I brought my Android tablet here, and they make an app that will, let's see, they make an app that will talk to this. I should plug it into a source, but anyway, this is showing me on the tablet what you see on the meter. So why would you need this? You know, need is not a word that hams use very often. Why would you want this? Well, one need is, now Mike Owens over here is like a master electrician, and I can imagine situations where you're working in a high voltage environment where it's kind of dangerous to be where you are when you're working around high voltage. So one reason they make these devices is you turn the power off, you go connect your meter to wherever you want to measure, and then you get away from it, and you turn the power back on, and you watch it on here. And this is how you don't have to stand next to the 5,000 volts that you're worried about. If you sneeze, you know you're going to hit a live wire. So this is a kind of neat feature for safety purposes. There's a data logging feature, but you can do from here pretty much everything you can do on the meter. Whatever you tell the meter to measure, it will track it over here. I switched it over to ohms, and now it's showing the ohm scale on the top of the tablet. You can also do this over a USB cable. They make another device where you plug it in, but I figured if you're going to use it, the wireless is the way to go. It's far more practical than having to be tethered to the device that way. So anyway, that's a neat way to check your measurements from a distance. While I'm talking about these Keysight meters, I've never bought a digital voltmeter that came with a 170-page instruction manual. So that's the book that comes with these two Agilent meters. It's a ton of information that they tell you, and it's like, you know, reading a manual for a ICOM 7600 or something. It's a lot a lot of information there. And that comes with it. You have to print it yourself. They don't give you a manual, of course. If nobody gives you a manual anymore. It's all online. One difference between, I'll just say, between the $20 meter and, say, the $200 meter is there's a lot of quality that goes into this in terms of filtering, low-pass filters, and these are high impedance devices, the high-end meters, where if you put it on a circuit, it's not going to load the circuit down. They're like 50 megohms impedance, I think, on the voltage ranges. Yeah, so if you put it on there, the fact of connecting the meter is not going to drop the voltage down to a point where it's actually affecting the reading. Let me show you another meter. This is also a Keysight Agilent meter. It does, see the little display when I light it up there, it's got a three-digit display. These have, I think, five digits on that. But this, with the meter leads, it does pretty much the same stuff. Not as many functions, doesn't do capacitance and temperature and some of these other things, but this will read voltage, resistance, continuity, and I think you can read a few other things too. But let me show you. Oh, the main reason I bought this is, anybody know? No, I don't think anybody. Mike knows all this stuff. This is right. This is a clamp-on current meter that will measure current without having to actually put, the meter in series with the load and the source. So if you want to read how much current something is pulling, you put this in the positive side of the supply, and it'll read the current. You can literally take this out to your car, put it around the positive battery terminal, start your car, and you can see how much current your car pulls, because it'll go up to 600 amps, and it's all inductively coupled. And you can tell it to store it in the device, so you can go back and look at it later and see what the peak reading was. Because the peak reading when you start a car, it only lasts for a second or two when it pulls that huge amount of current to turn the engine over. And if you want to know how much it's pulling, this will tell you. You can go in your, I don't recommend this for fun, but you could go in your fuse box and see how much current a particular circuit is pulling. But it's not something you play with. But I had a Volvo station wagon many years ago, and the battery was draining like every night. I'd go down every day, dead battery. I could not figure out what was killing the battery in the car. I started disconnecting things, and it was still a dead battery. So I put I think I had my old Simpson 260 analog voltmeter, which most of us have been doing this for many years. You know what a Simpson 260 is. And I had to carefully, because it would do a maximum of 10 amps, and more than that, you could blow the fuse of the meter. But I knew it was a low current drain, and I had to put it in series with the battery, and I could see that it was pulling, like 150 milliamps all the time when the car was turned off, and everything appeared to be off. And I was going through and watching the current. I was reaching under the dashboard, pulling fuses out to see if I could find a fuse that would, when I pulled it, the current would go to zero, and that would at least tell me where my problem was. If I had this, I could have just put this in line with it, because this will read down to milliamps as well. I could have just put this in line. I wouldn't have had to put the meter in line, trying to hold the meter up, and I could have done the same thing without all the hassle of trying to put an inline meter hardwired into the circuit to find where the drain was. Anybody want to guess what the issue turned out to be? It'll take me a week to find it.
Light in the trunk. You left your interior light on.
It wasn't the interior light. It was the glove box light. And the micro switch wasn't quite enough. It had given up the ghost there. And the switch was still working, but there wasn't quite enough tension when you closed the glove box. The only way I stumbled onto it was I turned off all the lights in the garage where I was working, and I looked inside the car, and I could see just a little bit of light inside the glove box, and that's how I figured it out. And you want to guess how much it cost me to fix that problem? Well, don't count the $1. I didn't buy this. No, it cost me 1 cent because 1 cent exactly. I took a penny and I taped it onto the glove box to put a little more onto the micro switch. And then when I slammed that glove box shut, there was plenty of pressure. It worked like a charm. So it was literally a 1 cent fix on that. So that's the clamp meter. I mean, it does everything else, but I bought it for clamping purposes.
Well, that was common sense, wasn't it?
It was.
Oh, geez, come on, Ken.
Let me.
That's funny, brother.
If any of you have power pole on your radio equipment and you want to know what it's doing, this is a little multimeter that's made specifically for power poles. It's got power poles on both ends for the load and the supply. And you plug this in, and I didn't bring something, a supply that has power poles for it to light up. It's got a little backlit LCD display. It'll show you the voltage. It'll show you how much current your radio is pulling. I plugged this into one of the mobile radios for a friend a couple of months ago. We keyed the transmitter. Well, it's pulling 7 amps on the 25 watt position, and it's pulling 12 amps in the 50 watt position. So it's kind of neat. It'll tell you a lot of things about DC voltage, tell you how many watts it's pulling. If you buy this one, this is not the one. Anyway, I have 2 of these. One of these has the name PowerWorks on the label. They're one of the big distributors of power pole devices. It's $50. If you go on eBay, it's $15 for the exact same meter, but it doesn't have the PowerWorks decal on it. So don't rush to buy the $50 version.
Tells you amp hours too.
Yeah, it does. Amp hours for battery purposes too. Yeah, it's really got a lot of information on it, and it's a pretty neat deal.
How many amps will it read? You know,
I think it'll read up to 50, maybe 25 or 50 amps.
It's a power pole connected to 50.
Well, that's the other issue. This has got looks like number 12 on here. I wouldn't test it more than about 20 amps. I think that's the maximum I would test it on. I think it'll read it, but the wire might not survive very long if you do that. Yeah. Now, these handheld meters are great for portability and lots of things, but sometimes you are in a bench environment, and all of these, for the most part, well, all of them actually, every one of them, will time out to save the battery in these meters after so many minutes of inactivity. This one is still going, but the OLED display has already turned itself off because this thing sucks batteries like crazy because of the display. Even the cheap meters with the disposable batteries will give up the ghost eventually, so they build in a power saving circuit to turn it off after so many minutes of inactivity. But if you're in a bench environment and you want something that you want to read all the time and it stays on, this is the bench version. This is a digital multimeter that does the same things as these Agilent meters do, and it stays on, and it has six digit, they call it 5.5 digit display. So because of the size, they can put a bigger display on here, and it reads all the same stuff: voltage, resistance. I think this one does capacitance. Now, this is a clone of an Agilent 34401, which was kind of the gold standard of bench meters for many, many years. They sold for about $1,000, I think. You can still buy the Agilents used all the time for $900 now. You know, they kind of held their price pretty well. But this was an eBay find. It was $105, and it's a Chinese clone. But is it as accurate as an Agilent? Well, I don't know. Let's find out. How do we know whether our meters are accurate or not? Well, one way we can get an idea is we can take a battery, and we know what the battery voltage is, and we can put it across the meter, and we can see what it's reading. Now, that doesn't tell us a whole lot because batteries are not necessarily accurate devices, but if you test, say, 4 different meters, and they all read the same thing, that is 1.5733 volts on this 1.57 5-volt battery, which is pretty normal. They're not exactly 5 volts. But if you tested all of these and they all read exactly the same thing, well, it's more likely that your meters are accurate because they're all going to read the same thing. It wouldn't be just fortuitous if they happen to read the same thing. So that's one way to get an idea. But if you want a more precise way to tell the accuracy of your device, this little device here is a low-end voltage reference standard that produces four different voltages. And I turn it on by pushing a button. It lights up red, and it's hooked up to the meter here. And this is supposed to be producing 2.5 volts DC. And on this display, it's reading 2.4975 volts. So pretty close. And you say, well, how do we know that the Chinese guy that built this thing, has any reference here? On the back is a little sticker that they put on there that they have tested this device with the Agilent 34401A, the gold standard meter. And he hand wrote what it reads on his meter that he, in essence, calibrated this with. And he said when it left his factory, it was this 2.5 volts is reading 2.49780, and I'm reading 2.4975. So pretty darn close. So this is the 2.5 volts. If I push the button on this little device one more time, I'm going to go to the 5 volt output, and I'm reading 5.0011. And on his Agilent, he got 5.0014. So pretty darn close. We're off by, 3 or 4 microvolts. This also has a 7.5 output. Let's just see what it does. We'll go to 7.5. He says, showed him 7.4961. I'm reading 7.4959. Ooh, I'm off by 2 microvolts between, on my $100 meter versus his $1,000 meter.
Did we check that Harbor Freight free meter?
Yeah. Check this one versus another one. Was that the question?
No. Have you checked the accuracy of the Harbor Freight?
Oh, the Harbor Freight meter. No, I haven't.
Well, I would be interested to put that on.
Yeah, we could. Well, I'll take my low end one here in just a second. I'll test it on and I did do it a couple of weeks ago. And the $20 meter is not that far off. I mean, it's not bad. The last standard on here is a 10 volt scale, which he said reads 9.9993, and I'm reading 9.9990. So this is a pretty good little way. This is, again, made in China, has a rechargeable lithium-ion battery in here, and you plug a cell phone charger into it to charge the battery up about every 6 months. And I've never run it down. I don't know how long it'll last, but I charged it up last night, and it produces a pretty darn accurate reading. And like I say, I compared it to the HP, called HP, but they're Keysight meters, and they are still within the calibration period, and it shows you that it's pretty accurate. So if anybody brought a voltmeter and want to plug it in, we'll find out how close you are with this one here tonight. So that's the calibration. The neat thing about the bench meter is, I don't know if you do anything, I never have needed this function, but this is something that will measure what they call 4-wire resistance. And 4-wire resistance measurements uses 2 sets of test leads to go across the load, the resistor, or whatever. If you're looking at very low resistance devices like a 2 ohm resistor, you want to see, is it really 2 ohms? Milliohms?
Looking for active channel resistance.
Okay, yeah, then it's something we probably would never really need, but by using this technique, it eliminates the resistance in the test leads, basically.
4-wire measurements is really what takes it from being a handheld device to a bench.
Right. That's one of the big differences for people that need accuracy for super low resistance measurements. To me, the utility is it stays on all the time, and I can easily read the display. If I'm sitting on the bench, I don't have to reach up every 5 minutes and turn the handheld meter back on because the power saving function timed it out. This thing just keeps on reading. Yeah, these, by the way, you ever hear that ITT Tech school that was a training school? They went bankrupt earlier this year, and a couple of guys on eBay bought all the test equipment that they had and were selling them on eBay. And that's, like I said, $100 basically for this. I think they had a few other things that I missed out on because I wasn't watching eBay in time to see what it would do. But that's I would like to have had the key site meter just because I've got another key site meter. But for the difference of $900, I'm perfectly happy to spend that $900 on something else and just use that one. All right, let me see what else I want to talk about quickly because I'm going to turn it over to Brewer here. He's going to show you the really expensive stuff here. This is a frequency counter that I bought on eBay. I wrote a little article a couple of years ago about this in the club newsletter. I'd always wanted a frequency counter. I got by for many years without needing one, but at my age in life, like I said, we're now at the want stage, not the need stage. And I knew I wanted a good frequency counter, and this one actually says Agilent on it, and I think this one may be made in the U.S. A lot of the stuff they've moved offshore, but at a certain time they were making them in the U.S. They make different quality time bases, the 10 megahertz time base in these. You can buy one that has just a simple non-temperature compensated oscillator, and the accuracy is pretty terrible. They make a medium accuracy one that's not bad. They make one with what they call the high accuracy oven control time base, and then they make one with a super high accuracy. This is not the bottom, it's not the middle, it's not the top. It's one below the top. It's the high accuracy time base. But I have in the box over there, I decided not to hook it up tonight just because we were running out of places to plug things in. I've got a rubidium 10 megahertz standard that runs off of another 10 megahertz oscillator that's what they call a rubidium disciplined oscillator. There's some electronics that maintain the accuracy. It has an oven in it. It gets to a certain temperature and it holds that. And that adds a couple of digits of accuracy to this as a time base. And then just this week, I got another Chinese eBay find. This is Jim's had one of these for a while yet. I've been waiting for the right one to come along, and I just finally decided to get this one. This is a GPS disciplined 10 megahertz oscillator. It's got what they call a Symmetricon, which is a company that makes GPS disciplined oscillators. These things, this one and the one in the box that's the rubidium standard, they come out of cell sites. Cell sites they have to have some type of timing to make cellular telephones work. Highly accurate timing. Every cell site's got to be on the same time, down to microseconds, or they don't work like they're supposed to. So they put rubidium standards in, and then they went to something else, and that was the GPS disciplined oscillator. This came with a power supply and an antenna, one of these little button antennas like this. It's got a 30 feet of cable in it. I stuck it out the window, put it actually sitting on my generator outside my hand shack, and I got like 4 satellites, and I got a lock on it, and it was showing me time and my location and all this, but I thought 4 satellites is not really enough to have a high accuracy. So I went on eBay and I found one of these external, I didn't bring it tonight, it's about this big, looks like a little cone-shaped device that they use at cell sites to get it's got a 40 dB preamplifier and a high gain antenna for 1500 megahertz, which is the GPS frequency. And I went out to Lowe's last night and I bought a 10-foot piece of PVC pipe. I've got to somehow get a way to stick this on my deck without my wife noticing it's there. It's kind of tall. And
Bird feeder.
Yeah, maybe I got to do something. Every now and then she goes out and looks at the deck and says, "You've added an antenna." And I'm like, no, they've been here. And sometimes it's true, and sometimes it's not. Yeah, maybe I can, because she loves cats, maybe I'll tell her it's a cat scratching nose or something. But anyway, I had only like an hour last night in the dark fumbling around with my new GPS antenna, and I went just still sitting on the ground, not up higher where I hope to put it permanently. I think I was up to 8 satellites, and it seemed to be more stable. And I'm hoping when I get it where I want it, I'll get 10 or 12 satellites, and it'll then be my gold standard to drive the frequency counter. But the frequency counter is this will go up to, I think it's 3 gigahertz. I put a prescaler in it. If you buy the HP prescaler to take from 225 megahertz to 3 gigahertz, HP charges $1,000 for that option in addition to the price of the counter. But there's a guy in Poland that sells a prescaler that is literally plug and play. It plugs into the slot that HP left in here. It plugs, the ribbon cable plugs into the circuit board, and you mount the little BNC connector in the knockout on the front, and now you, for $80 delivered, you have a 3 gigahertz counter instead of a 225 megahertz counter. So if we key the radio and get it gradually closer, you'll see, I think I'm transmitting on 447.2 it says, and it says 447.2002. It's moving around a little bit.
You're talking.
But yeah, I don't think we're keying up. I don't think that's a repeater input, hopefully, so.
No, I meant you're talking, you're causing
Yeah,
FM.
the modulation.
Oh, yeah. That's true.
Frequency modulation.
That's true. It's moving around from the audio and the signal. But anyway, this is kind of fun to, see if your HT is on frequency. It's fun to do other things, and you can adjust the gate time and read it down to, I don't know, 0.00 hertz, on a signal in the 400 megahertz range. It takes a while to update when we do that, but it's pretty fun just to think. And of course, I was sitting there the other night. I'm glad nobody saw me because they would have thought I was absolutely crazy, not just a little crazy. I was looking at the 10 megahertz output from the satellite to see how many zeros I could get, and it was like better than watching TV. I was fascinated.
Nowadays, that's true.
Yeah, I mean, it's like, my parents told me that when I was a child, and Channel 6 was the only TV station in town, and they didn't sign on until about 5 o'clock in the afternoon because they didn't have any programs. They would run a test pattern. It used to be called a monoscope. It was a test pattern with lines and circles and all of this. Indian, yes, it had an Indian chief's head with a headdress on in the middle of the thing. And they said I would watch the test pattern for an hour before the How to Duty show came on. So
That's what happened to you.
easily entertained by electronics, and I was trying to see how many digits I could get on my GPS oscillator last night. Okay, I'm going to start to wrap this up, but I want to show you 2 things that are not really ham test gear, but they're very useful devices. Now, Mike Owens can't answer this because it's unfair to. Anybody know what these are? 2 birds of the same thing. Right. They're non-contact voltage detectors. And I'm like, I bought the first one of these like 7 or 8 years ago, and I'm like, where has this been for the last 25 years? I found how useful it is, and when I'm doing things around the house and I want to see if there's a live circuit before I go doing something. So you saw what it does. If you don't have to plug it into anything, you don't touch any voltage, you just get near 110 volts, and it goes off. And it's wonderful. If you're going to pull a light switch off a wall and play with it, you want to make sure it's not hot. You don't have to go, switching breakers and seeing if the lights go out. You just put this up to the device and see what it does. This is a Klein, and this is one that will do, it'll tell you that it's active by turning green. This one has another mode on it. This is a dual function one that'll do. That's 110 volts there, and somewhere on this table is a battery. Where is it? Power supply
Right in front of you.
There it is. Here's a battery. Let me see if I'm on the low voltage version of this. I think you have to get it in the right mode here. It's supposed to sense from 12 to 48 volts on the lower DC. This will do DC. This one will read DC on the I almost done that.
Well, actually, versus not. And we all started in the same general bucket of SWR meter from Lafayette, you know, we really thought we were going somewhere with the Berg watt meter. That's been my standby. I'm Brewer Peaton. I'm also the president of the MRA. A couple of announcements. Channel 35 called me on Wednesday and said the Channel 35 tower's coming down starting like in a week or so. So we really did have to move, and there's the proof, the tower's coming down. Interestingly enough, the chief tells me besides us cherry picking a few things out of there, they're going to bulldoze the whole building with the transmitter in it. And for us old broadcasters, we're like, oh, how can that be? But here it comes. And one other thing, the MRA, as you may know, suffered a transmission line damage in May. We fixed it. It took us about $500 to get that fixed, but in general, the MRA treasury is sinking. We probably have $1,500 to $2,000 left. We would appreciate anybody that uses the 145.43 to sign up and get your annual dues paid. So I'm here.
We'll give the website.
Okay. And the vice president will inform you where the website is.
Jim?
MRARichmond.org.
MRARichmond.org.
Sorry.
Or just, you know, talk to somebody on 543 and start waving cash, we'll take it. The repeater's in good shape, it's healthy, we have a spare repeater if we get lightning hit. Barring any more tower jockeys on channel 6, we'll be okay. My subject for tonight, which I was going to spend 30 minutes on, now I've got maybe 10. And I'm going to just put this in as a teaser because I'll come back at a later date and try to teach this stuff. As part of my day job, I worked for what was Hewlett-Packard, then Agilent, now Keysight, for 30 years. Part of my day job is teaching classes on things like network analysis, spectrum analysis, you name it. And those classes go on for days. They, you know, we basically get paid to go in and teach a bunch of either college new hires or new sailors, new airmen. Let's talk about spectrum analyzers. This is something that most of you amateurs should kind of get a feel for. What does this look like to most of you? Anybody want a hazard guess? Receiver, yeah. And indeed, the early spectrum analyzers were nothing more than receivers with mechanical tuners to tune the dial, some oscilloscope to paint a picture. This block diagram is pretty important, and it's changed. This kind of represents everything that's in a spectrum analyzer, and we have one here we'll show you in a second. You'll note you got your input, and you have this thing that looks like a resistor. That's an input RF attenuator to throw away power that you don't need if you're in that situation. Pre-selection, we're all familiar with that. With our HF radios, it's better to be able to pre-select the 40-meter band or some part of it before it gets into the rest of the receiver. And then the fundamental architecture, everybody remember from studying what a heterodyne is? It's basically a mixing of two signals. Well, this is a single stage of heterodyne, local oscillator, mixer, input spectrum. Then you got your IF, like you would in the receiver, your ham radio. The big difference here in spectrum analyzer is this coordination of a sweep generator that automatically tunes the local oscillator up and down the band, and a display that takes the output of the processing chain and makes you a nice Cartesian plot of power versus frequency on the x-axis. Now, this is kind of the way they were back in the 1940s and 50s. As time went on, this stuff got better and better. Digital electronics started to do things like this: the resolution bandwidth filter, the IF filter, gain stages, detectors, and so forth. In the early days, these things were literally like low-pass video filters done with LCs and RCs and so forth. These days, all the IF and the display is digital. You've heard of digital IFs, you've heard of SDR. You've seen this IC7300 that's kind of got the fame right now. It has a built-in FFT-based spectrum analysis, plus or minus where you're operating. Very useful for finding your hole when you're trying to do a scan on a busy frequency or during field day. Another point about this is that as time went on, instead of having to use a heterodyne scheme, if you have a digital sampler out here in this IF, basically an A to D converter, running at very high sample rates, say like a gigahertz of samples per second. Then you have a Nyquist bandwidth of 500 megahertz, which means you really don't need to do this frequency conversion to get to an IF. The whole thing becomes an IF. So these boxes that you see, and they're all over the place, the one we're playing with is called a Radio Spectrum Processor 2 from SDR Play. Basically a little block, a small box with a USB pigtail on it. In the third generations, these products have been along for 10 years. The new ones have pre-selection, attenuation, unbalanced and balanced inputs. They've basically taken what was a raw sampler and turned it into a fairly well pre-selected digitizing receiver. And when you throw in the user interfaces that the software has, you can get your spectrums, you can use multiple demodulation, digital demodulation slices within the information bandwidth of that sample. So this one sampler could be sampling at 1 billion samples per second, yielding a 500 megahertz information bandwidth, and all the signals are in there. You just have to go in with the digital demodulator and select them out. I think that SDR Uno is one of the software packages that works with these things, and it actually has not only the FFTs and all the spectrum displays, but it'll let you set up multiple demodulators at different points within the information bandwidth of the digitizer.
He's talking about a $100 device you can buy at HRO. It's a SDR receiver that goes from 1 kilohertz to 2 gigahertz. A little black box plugged into the USB port.
Smaller than a handheld.
You've got a dongle device right there that can
$4 one.
Right.
Right, okay, and there is a whole set of dongle-based digitizers. There's a chip, an RD, something that got very popular. It was used in the dongle-based receivers for digital television. And then some ham figured out, hey, I can do stuff with this, and they basically become ubiquitous. They're everywhere, they're like $20.
Comment?
Question?
I've been playing with WIP, SDR.
Right.
I've had more fun with that. I've
It
learned
is
how
a
to
lot of fun.
recognize upper and lower side band tuning, bandwidth, and everything. It's on the internet. Let's do a good one on it. WIP, SDR.
A lot of good cheap play there, and like I said, 150 for this nice one that's the 5th generation, but those things are like 20, 25, 30 bucks. All right, so anyway, I wanted to bring up the general analyzer block diagram. Then I'll bring up an example. Let's see here. So this is a current day product made by Keysight. It's a spectrum analyzer, network analyzer, power meter. It's about 10 or 15 instruments in one box. I was just playing with this during the
So when do you own one of those yet?
That's not quite within my grasp.
I'm going to drive it from the front panel here. So real quickly, I wanted to show you what a network analysis looks like. And a network analyzer, differentiated from a spectrum analyzer, is it has a built-in source. So it can stimulate, knows where it's stimulating frequency power-wise, and then sweep itself up the band and take magnitude and phase measurements and recreate everything you've ever heard of, SWR, DOSWR, impedance, and so forth. And essentially, network analysis is stimulating the device under test. If it's a filter, it's an antenna, whatever. You stimulate it, you look at what gets reflected off of it, and you look at what gets through it. And what gets through it part is the forward gain or loss. When you're looking into the port, it's the port match, this one of the port, and the output parameters are a symmetric set. So essentially, if you look here, we've got Smith charts plotting essentially the impedance. I'm sweeping from, this is a 10 gigahertz dummy filter. I'm looking at the input match, the output match, the forward transmission of this pass band of this filter, and the reverse transmission of that filter. So filters are symmetric, usually reciprocal, usually easy to look at, but you could do the same thing with the transistor amplifier and so forth. So vector network analysis is very handy. It's all automated. It gives you a lot more information than, say, an antenna analyzer, because essentially it makes these fundamental ratioed measurements and then converts them into whatever parameter you're interested in. S parameters are the formal notation when you take this stuff in college, but an S parameter can be converted into all the things we've used. Question?
So